Okay, so now we will solve this problem. You can see here, this is the net power production of a heat engine. So this is actually the schematic here. So if we read the question at first, heat is transferred to a heat engine from a furnace at a rate of 80 megawatt. If the rate of waste heat rejection to a nearby river is 50 megawatt, we need to determine the net power output and the thermal efficiency for this heat engine. So this is actually the schematic. You can see the furnace and this is the nearby river, and we can see actually the rate. See, the heat is transferred to the heat engine. So this is actually the heat engine. So heat is transferred from the furnace to the heat engine and the rate is 80 megawatt. And when you can see the heat rejection, the waste heat rejections nearby river, it is actually 50 megawatt. So that's actually given. So we know from the theories when we discussed actually the heat engine and the net power output or the thermal efficiency, we discussed all the theories, so we already know. So if we start with the analysis, then we can say we have in this system, actually in this this is the heat engine, you can see here. So we need to calculate the net power production. So we will assume that the heat loss through the 5 or the other parts, it is negligible. So I actually don't want to write it here. So if I start with the analysis, so let's say this is the analysis. So here this furnace, you can see it is actually the high temperature reservoir, the heat reservoir we discussed earlier. So this furnace, this is actually the high temperature reservoir, and that's why we can say, you can see we just use this the Q haze, you can say the hot, all right, or the high. And the river, this is actually the low temperature reservoir. So you can see we denote this heat transfer by QL, right? So we did that. So that's why we can write it's actually in this question. If you see this schematic, it's given here. So what you can write that Q haze, this is very easy problem. So this is 80 megawatt and this QL, it is actually 50 megawatt. Okay, so that we know. So from the theories, we know the net power. Here we need to calculate the net power. So the net power output for this heat engine, it is actually, we know from this formula the net power, we can say this is W net output. It is actually the Q haze minus QL. This is we got from the theories. We already discussed that. So it is 80 minus 50 megawatt. So it should be 30 megawatt. This is actually, the W net out. So what we got here, this is actually the net power output. This sort of question is actually important for the, the quiz. So you have the quiz next week. So yeah, you can expect some similar problem like this. So we got, you can see 30 megawatt. That's actually the net power output. But now we need to calculate the thermal efficiency. And this is also very easy. From the formula, we know the thermal efficiency. So the thermal efficiency, we define, this is the Greek eta, and we can say T haze, this is the thermal efficiency. It is actually the ratio of this net output, that means the net power over in the Q haze. The hot temperature reservoir, the heat rate from the hot temperature reservoir. So this is actually we know from the formula. So in this case, we got, this work output is 30. So if we write it is 30 megawatt and the Q haze, this is 80 megawatt. So it will be actually 0.375, or you can say it is 37.5% if you just convert it into percentage. So this is actually the efficiency. See the thermal efficiency of this heat engine. So that's actually the solution. So it means the heat engine converts this 37.5% of the heat that it receives to works. Okay, so this is the efficiency. So heat engine, it is receiving the heat, and it converts 37.5% work. So that's actually the solution of this problem. I believe you understand. This is very straightforward problem.